Now, just like we looked at the input devices, in the output devices, we shall also look at the introduction as we looked at in the input devices. Now, in this lesson, I expect you to expect the following. I expect you to know the introduction to what an output device is. I'll take you through the forms of computer output devices and then the computer output devices. Now, looking at the introduction, remember as we explained in the input devices, for the input devices, that whenever we're looking at these devices, all of them actually emerge from the process through which data undergoes to become information. Now, if we normally say that when we need to get information, we have to collect data. Now, this data is collected using different means. You can collect the data using you can use interview method, you can use questionnaires, you can use question and answers, you can just interview people. Then you collect your data. But this data is not yet meaningful. That's why we have to undergo the process of processing the collected data. So we collect the data, then we input it into the computer as an input data. Now, in the computer, we have the brain, what we call the CPU, or the central processing unit, that does the processing of the information, the data. So the data will be processed into information. Now, once the data is processed and once it becomes information, then we can understand the information. It's like a name like Bernard. When you need the name Bernard comes from from some type of data. And most of you are probably asking yourself what data is. Now, data is a collection of raw and processed facts, figures, letters, or numbers. Okay, so the name Bernard is actual information because we processed certain data. Probably the type of data we processed here is letters. So we put different letters together. That would be the process of us putting those letters together would be what we call processing. Then what we come out with after putting them together, the name Bernard becomes our information. Now, I think that's enough introduction for that. Everything I've just been saying is actually summarized into this image. The very first image you see there is an image of a computer receiving inputs, different types of inputs. You can see time, you can see the card, settings, messages, and so on. All that input is put in the computer. Then the processing is done by the central processing unit in this other image. And then, of course, we have the output. The output we see here is in terms of the printer printing out output as hard copy, and then we see an output on the screen of a phone as a soft copy output. Okay, that's enough introduction. Now, today our main focus is on the output devices. These output devices, we are using them in our daily lives. Even right now in this lesson, most of you are able to hear the words I'm saying in this lesson because you are able to hear me through an output device, probably the speakers if you have them on your desks, or earphones which are also having speakers at the ends. So we are using input devices nowadays. You are able to see the screen I've just shared on your screens because I'm using an input device to make sure that you are using an input device to see this. Now, there's some of these input devices, the common ones you can know of, are the monitors, the printer. The printer, we know it is a hard copy output device, which brings out output on papers. And then we have speakers, which give us output of sound. Even headphones are output devices. Then we have a projector to project whatever we are viewing on our PC onto a screen through the projector. Then we have touch screen. Most of us are using touch screens right now. Some of you have touch screen laptops, others are using touch screen phones to attend this lesson. But all those qualify to be output devices. We have the plotters. You can find these in Uganda if you go to Nursery, where people are printing very large images on billboards, on signposts. They are printed using what we call a plotter. Then we have the GPS computers, which actually help you to see where you are right now at a particular time as you're driving in your cars. So all these are output devices, and they help us understand how computers actually work. So if we move on to the next, we have to understand that the computer output actually depends on the forms of computer. So a device, a shape of a device, or what a device is, depends on the type of output. That brings us to what we call the forms of computer output. The forms of computer outputs, members, we have three major forms, and we have a form of computer called sound. Now, with sound, we're talking about sound signals being transferred from a microphone or probably from the computer to a device which will be able to echo this sound out or to make it be heard by. So the characters and text are also a form of computer output we normally use. Now, for the graphics being the form of computer output, here we make use of still graphics, and we also look at images which are moving, for example, the GIF images, or we look at videos. Now, when we have any kind of data involving the images and videos, those qualify to be graphics. And then we have output devices that they help us output this kind of data or this kind of output. We see the images right now on our screens. As you can see, you see it as an image. That means the form of output we are receiving from our monitor right now are the images we see on the screen. So these are the three major forms of computer output we can use. Now, moving on, if we look at the types of output devices, now members, the types of output devices are generated. Actually, we categorize them according to the type of the kind of output they generate. Now, we have two major types of output devices. The very first type of output device I want you to understand is what we call the hard copy output device. Now, here we call it a hard copy output device because the kind of output we receive from these devices is a hard copy. We can touch them. They are tangible. They are tangible hard copy output devices. So why we call them a hard copy? Because of those reasons. They are tangible. We can touch them. We can feel them. And we know certain devices which provide such kind of output. Now, when you look at printers, we're able to see what printers can. We are able to see what printers can output. We are able to touch it because they do their printing on a piece of paper which is hard copy. So that's why they qualify to be hard copy. The other example you could give are the plotters. At the beginning of the lesson, I told you the plotters are used for printing large amounts of large images on billboards, on signposts, and so on. So you'll find that the papers or the material onto which images or the characters are printed on a plotter is different from that of a printer. And then we also have the soft copy output devices. Here, the kind of output is soft copy, meaning we can't touch them, but we can hear them and we can also see them. Now, the output you're seeing right now on your screen, you can't tell me that you're able to touch it. Even when you're touching the screen, doesn't mean you're touching the output of the output, whatever is being output on the screen. So the soft copy output device generate outputs that we can't feel, that we can't touch, that we can only see and probably hear. And examples of those include the projector. The output the projector projects onto the screen. It's soft copy. We can't touch it. Okay, you can't touch it. Then the speakers also provide sound. The sound from your earphones right now, you can't touch it. If you can touch it, then you're on another level. So these are the kinds of devices. So any computer device which produces output that you can't touch qualifies to be a soft copy output. Moving on, we said we have the computer devices, and these computer devices are so many, and we gave examples of the most common ones. Now, in this slide, we're actually going to look at how we can make use of, how we can understand these devices into details by looking at them one by one. Now, starting with what we know as the monitor. The monitor is an important output device. Okay. Now, some people call the monitor a screen. Others call it the video or the virtual display unit or the video display unit. So these are the devices which are used to get the processed data out of the computer to be displayed onto the screens, okay, to the users. Now, the device, any device which can display information for you onto its screen, okay, to be processed, to be seen by you or to be analyzed by you, the user, qualifies to be a monitor, okay. So we have different monitors. We are going to look at examples, but what you must understand is that for a monitor to do its work, it must be having what we call an adapter. Now, someone has asked in the chat section that what an adapter is. Now, an adapter is is a chip. Sorry, an adapter is actually a chip which you find in these devices to help them display whatever they're supposed to display in different colors. Now, in order for them to display, actually the adapters are categorized into two standard formats. They are categorized into two depending on the colors they can output on they can display on the screen. Now, those two types are what we call the monochrome adapter, and what we call the standard color adapter. Now, starting with what the monochrome adapter is, in your physics probably you've come across the word chrome. Chrome is something to do with colors, okay? So the word mono means one. So when you look at monochrome adapter, it is actually trying to define itself within its word. So this adapter helps the displayed screens to display data or to display only one color, okay? Now this color can be the white, it can be a green or amber. Amber is yellowish green in the background, and these are less popular today. You can't find them anywhere most of the times. If you find them, then you will be probably lucky. They are rare, but they display on what we call a black background, okay? They display on a black background. So these colors I mentioned to you about, the blue, the white, the green or amber color they used to display information in, is displayed onto a black background. So the standard color adapter, which displays several colors, okay? The standard color adapter displays several colors. Now, we have these adapters, they are the common ones, because even right now, there's none of you who is only seeing one color. The screen I've shared has a lot of colors that we can see. It's because of the adapter it's running. So these adapters come in different formats. We have the VGA adapters, which display information. We have the SVGA, which is an acronym for Super Video Graphics Array. Then the VGA stands for Video Graphics Array. We have enhanced graphics adapters and so many. So there are so many types of these standard color adapters. So let's look at the functions of a monitor. We say a monitor is very important. The very first function is that it displays the progress or the output of the user's commands, and this helps to decide on the next step. Now, right now, I'm able to see that our screen, our meeting is supposed to be for about 40 minutes. Time will reach when the screen will display for me the amount of minutes I'm left with to complete the lesson. So, because I'm able to see the display on the screen, I can actually decide on what to do next. I can decide that before the time ends, let us go and join in the second session. So in the second session, we shall have a continuation of whatever we have not finished in the first session. Now, it makes a computer productive is a second function of a monitor. How does it make it productive? It has interactive tools due to its instant user feedback. Now, we can be able to use, right now we are using Zoom, okay? We are using Zoom to conduct a lesson. But because we are able to display how Zoom works, it actually makes whatever we are doing more productive. But the productiveness of whatever we are doing comes in because we are using a computer. So it makes a computer productive. Then the other function of a monitor is that it can make computing a very continuous process due to its ability to provide constant visual feedback. So every time you are using computers, because they are very they can satisfy your needs easily. okay, especially the needs of a student. So it makes computing to be a continuous progress, a continuous process. Now, meaning today we are going to have this lesson, but you'll see that in the next day, as this session ends, we are going to have the next session, meaning we are still going to use computers. So computing becomes a continuous process. Even next week, we shall have the same lesson. Now, the types of monitor, I want you to look at types of the types of monitor. Now, monitors come in different types. Depending on the type you're using, you actually be comfortable, depending on how comfortable you are with the type you're using. So the different types are the cathode ray tubes. We shall look at each of these types. We have the liquid crystal display, we have the plasma screen, we have the touch screen, we have the organic light emitting displays. Okay, so what we also call OLED. Okay, now let us start by looking at the cathode ray tube. Now, members, the cathode ray tube are the very, very first monitors we ever used as computer people. Now, the cathode ray tube, as you look at in this image, it is very long. Why do you think it's long? It's long because inside it, there is a tube, a cathode ray tube. We call it a cathode ray tube because it has parts which it has a part called the cathode, which is responsible for shooting electrons onto a screen, which is covered by a very a photo substance, meaning a substance which can react to light, or when exposed to light, it reacts. Now, when the electrons are produced, the electrons move at a very high speed and they hit the screen. Where they hit, that area reacts. Hence, you see a certain color being generated on the screen. So how this works, several electrons are being bombarded at different speeds and at different energy levels so that they can display the images we see on the screens. Okay, so that is how a cathode ray tube works. Probably some of you have never seen how a cathode ray tube looks like, but if you get chance when you go back to school to enter the computer lab, somewhere in the corner we have a table where we have kept the cathode ray tubes, because we also used them those days at college. Okay, so that is what we look at as cathode ray tube. Now, when we look at the advantages and disadvantages of cathode ray tube, now the advantage, the very, very first advantage you should always think about is that it can produce fast and rich color output. Because of the electrons traveling at high speed and hitting the screen, you can actually see that the color is kind of rich. Okay, then the images can be viewed from a wide angle, meaning you can actually sit anywhere. So long as the screen is in front of you, you can see the image and you can see it with the same quality as if you're sitting just right in front of you. Okay, so excuse me. Now, the other advantage is that it is cheaper than the LCD monitor. Now, the liquid crystal display monitor is expensive, but because these other monitors were the very first ones, they're actually so cheap. So it's an advantage to us who are purchasing it. Now, the disadvantage of this cathode ray tube or the CRT is that it emits higher magnetic radiations that cause eye defects. Also, not only the eye defects, but also the skin problems, because electromagnetic radiations actually penetrate. They can actually penetrate through certain solids. Our skins are very soft, so some of these radiations can affect our skin and even our eyes, so causing the medical issues, probably even death after a long time. Because of whatever happens, because of the electromagnetic radiations, we have to use these CRTs in a very, very proper manner, in that you have to sit a little bit far from it as you're using them. Okay, so it also consumes a lot of power compared to the LCD, because energy is needed to produce or to generate the electrons and shoot them onto the screen. So those are the advantages and disadvantages of a CRT monitor. Now let us look at what we call the liquid crystal display, or the flat panel. Now this is the type of monitor that we are mostly used to. We use them in college whenever we enter the computer lab for our lessons. We also use them at our homes. You see, you have TVs which are actually monitors, and we use them for watching. Okay, now These ones use what we call a crystal inside. Now, electromagnetic radiations or electromagnetic magnetic fields are going to be exposed, or they are going to be bombarded onto this crystal, which will in turn change the react accordingly to form the images onto the screen. The images we can view. Okay. So those images are very, very clear because they are being produced from the crystal. That's why we call it the liquid crystal display. Okay. Now, when we are dealing with these LCDs, you'll actually notice that it has better advantages compared to the CRT, because first of all, it consumes less power compared to the cathode ray tube, making it very, very suitable for use. Then the radiations it also emits is less compared to the cathode ray tube, because now the kind of electromagnetic waves doesn't mean that because this one doesn't have a cathode ray tube, it doesn't mean that it doesn't produce a radiation, because still we use electromagnetic fields here inside to bombard them onto the crystal, which is found inside the computer. So those are the two major advantages we have over. Now the disadvantage is that it is more expensive than the CRT. So when you go to buy an LCD screen in the future, go with enough money. Don't go to buy an LCD and then you end up coming back with the CRT because the LCD was unaffordable. Then the images can be viewed from a narrow angle, not like the cathode ray tube. This other image, the images on these screens have to actually be observed when you're directly in front of them. When you move around, or you try to look at it from another angle, the images might not be clear. Try to experiment this using your laptops. Okay, try to tilt the laptop in a way that your face is kind of higher than the screen of the laptop, and try to look at whatever is playing on the screen. You'll actually notice that the images are blurred. They're not clear enough for you to understand them. Okay, so those are the two disadvantages of a liquid crystal display flat screen or a monitor compared to the CRT. Now, moving on to the next slide. Now, members, when we are dealing with monitors, we have to understand certain terms used. Okay, we have to understand certain terms used. We have what we call the screen size. Now, many of you who have ever bought a screen from the market or from shops, you'll actually notice that you always ask for a screen comparing it to their sizes. You tell them, give me a 24-inch screen, give me a 40-inch screen, then there are even 50 inches of screen, but you don't even know how it came to be called a 50-inch. Now, why we call it that is because we measure the size of this screen. The screen size is actually how wide the screen is, but we measure it in inches, and we measure it diagonally, okay, from one corner to the next diagonal corner. Okay, so in these images, you'll see that we have a smartphone which is being measured here, and it is 5-inch. We have a tablet or a phablet which is 7 inches. Then we have another tablet here. Then some of you have screens at home which are even 32 inches, and so on and so on. So that is what we mean when we say the screen size, how big the screen of the computer is. Okay. Now, we have what we call anti-glare. Whenever we are using these computers, the light it emits is very dangerous to our eyes. This light, we normally call it blue light. So this light causes eye defects and so on in the long run. But since that is a problem, we always come up with solutions as the people of computers. We came up with what we call the anti-glares. Now, the anti-glares are those screens we attach onto our screen such that the light effect or the blue light effect from the screen is minimized. It filters out this light such that the light we consume using our eyes is actually not going to hurt our eyes the way it would if we were not having an anti-glare screen. So in this image, you'll see that someone is trying to put an anti-glare onto the screen. Okay, in the chat section, I can see that someone is asking whether using a screen guard is also an anti-glare. No. And yes, why do I say no? There are screen guards which are just so transparent whatever light falls on it just passes through it. Those ones don't qualify to be anti-glare. Anti-glare only works when some light is being blocked. Then, yes, in the sense that there are certain screen guards which actually have the effect of the anti-glare. They're kind of dark, they filter out the light and so on and so on. So I hope I've answered him. All right, moving on. Let's look at resolution. Now, members, when I talk about resolution, they are what we call pixels. And we actually look at pixels in the next point to the term to understand is a pixel. Now, when we talk about resolution, we have to understand what a pixel is. First of all, a pixel is the smallest unit of an image in this format. When you look at this image I'm pointing at, this is an image of Mona Lisa. It's a very common, famous art piece which was drawn by I don't know who, but this is an image which was viewed on probably a phone and then zoomed. The same thing applies to you when you have your phone and you're viewing an image. Try to zoom it up to a point that you're able to see some boxes, squares on the screen, and the image becomes bright. Now, those squares you see are the smallest units that make up the picture as a whole. And each of those units is what we call a pixel. Now, when we put a pixel in terms of resolution, we're looking at the total amount of pixels a screen can accommodate. We'll have to measure how many pixels are the length and the width, and then we multiply to find the area. That gives us what we call the resolution. Okay, so we also have what we call the dot pitch. The dot pitch defines the vertical distance between two adjacent pixels. If we have, when you look at this image, it has been zoomed. Now they are measuring the vertical distance between two of them. This gives us what we call the dot pitch or the pitch pixel. Okay. Then we have the refresh rate. The refresh rate deals with how your screen can easily draw an image, or how it can redraw an image. Now, when you look at this image of Mona Lisa, I've already made it disappear. I'm doing this because I've seen in the chat section that someone is asking me to elaborate more about the refresh rate. Now, when I move back to the slide, you see the speed at which this image is redrawn after I removed it and I'm redrawing it. The speed at which it is drawn is what we call the refresh rate. I hope I've answered you clearly. Now, the speed always varies from one computer monitor, one screen to another. Mine might be fast, but for you, it might actually be slower because of network, meaning at this moment, my screen refresh rate is higher than yours, okay? So that is what we call a refresh rate. Then we have what we call the light emitting diodes. Now, the light emitting diodes are actually made up of very many LED bulbs which emit light when electric current passes through them. Now, there are monitors we have which are always using that technology, meaning it always has to be having current passing through the monitor, in that it only switches on the LED bulbs which make it light when current is on or when current is passing through it. For example, in this image, you see that this monitor is trying to send us a message saying hello, but out of all the LED bulbs, only the ones that form the image called the hello are the ones which are on, meaning the rest of the bulbs are not receiving current. Only the ones which will generate the message hello are going to be turned on. That is how the light emitting diode works. Okay, that's how the light emitting diode works. Most people use them in casinos to display casinos, to advertise casinos. And then I see in the chat section someone is saying that they are also used for advertisements by the roadsides. Actually, when you go to Kampala, at that junction, the traffic lights where you go and there's that crossroad where the traffic lights, there are certain screens by the roadside which are playing very small ads which don't even, they keep on repeating themselves. Those are the LED light monitors, light emitting diode monitors. Okay. All right. So that marks the end of monitors. Now let's look at printers. Okay. Now printers, we are going to talk much about the printers in the second, in the second session. For now, let us stop here because our time is going to elapse, and I'll ask you to immediately join for the next session using the same link I shared to you on your WhatsApp. Are we together? Okay. All right. Thank you very much for attending this first session. Please use the same link to join immediately for the second session. Thank you so much. Thank you. Now, let's look at printers. Now, we said printers, members, printers are very important. We use them in offices, we use them at home, we use them in our daily lives as students and teachers. Okay, some of these personal things, we are going to talk about them after the lesson, okay? All right. So, the printers are very important, members, because without printers, probably, the UNEB you did wouldn't be possible, okay? Because UNEB gives you questions on papers. These questions are being printed out by printers, meaning without the printers, you wouldn't even do the UNEB you're preparing for, or the UNEB which was already done by you guys, or even by some of us who went through the levels of education. Now, the printers are the ones which help us to do this. You get information from a computer and you print it out on a paper, okay? So the kind of output here we are seeing is a hard copy output. Now, we're going to understand printers into details. Printers are divided into two major parts, okay? Printers are divided into two major categories. The first category is what we call the impact printers. Just like the name states, impact printers, it means there's some kind of impact within the printers. These were the very, very first ones. We are going to see by the end of the lesson that these printers can actually be used under very, very extreme environmental properties. For example, they can withstand the heat, they can withstand mechanical problems, they can also be used when there's a lot of dust. They are not like the non-impact printers we are using right now, which we have to always cover to prevent dust from entering it. These ones, whether there's dust or not, it works. Whether the temperature is high or low, it is working. So they can work under harsh environmental conditions. Now, we're going to understand them in this lesson. How about 3D printers? 3D printers are not for our level, Teddy. 3D printers are not for our level, but just to know, to make others know what 3D printers are, these are the ones which print 3D objects, okay? But some of these are not yet there in Africa, even the 3D printers. In Africa, I don't think we have a 3D printer. If it's there, I'm yet to find out, okay? So, Teddy, the 3D printers, probably the ones you've seen in your nice movies, we don't talk about them here, okay? We only talk about the impact printers and the non-impact printers. But it's good to have knowledge about the 3D printers. So in your free time, you can go and talk to Google, you do some research, okay? All right, so the impact printers have contact with the print media. Like I told you, the word impact, it means there's something being hit inside there. So here the mechanism is in terms of heating, okay? In these printers, we have what we call a hammer, okay? We have a hammer, and then we have a wheel against which an inked ribbon is put. So when the hammer hits the wheel with the ink ribbon, it leaves a character on the paper which is going to be printed on. Now, if we start printing the characters on this wheel, you'll find that this wheel we use in these printers, they have the characters. So each time the printer is hitting the paper and the impact is being gotten by doing it on a wheel, which is covered by an ink, when the hammer hits that position of a character, it's going to leave the character on the paper. Okay, let me give you an example to help you understand this. Most of you in your primaries, if you didn't do this, then you didn't enjoy your primary level of education. Probably some of you still do it. When you get a coin, either it being a 200 coin or a 500 shilling coin, and you put a paper over it, you press the paper on it, and then you use the pencil draw, to shade just the shape of the coin on the paper, you'll actually see that the shape which is put on the coin, you can actually see it on your paper. What does that tell you? It is the same way these printers work. On the wheel, we have, on the wheels, yes, so Mjuruzi is saying, okay, we have this kind of mechanism in these printers. So we have these printers in different types, okay? In different types. Now, for you to understand it more, for people who have seen how typewriters work, it's the same way we can say the printers, these types of printers work. So they also come in different types. There's what we call the dot matrix printer. And the image you see here is for a dot matrix printer. Now, how do dot matrix printers work? We have to understand. Now, for the dot matrix printer, members, for the dot matrix printer, we have to understand that it is a set of steel pins that strike the inked ribbon onto the paper. Okay, so it is a set of steel pins. So these pins strike the paper, creating dots which form the characters. That's why we call it a dot matrix printer, because it uses small dots which are being printed onto the paper to form a character which is being printed. Okay, so those steel pins, very fast, they put those dots on using the ink. They put the ink on their tips on the paper, forming the characters we see. These dots are so small that sometimes we can't even notice that the character was formed from those dots. Okay, so that is how the dot matrix printers work. So the dot matrix printers, what you should understand is that they can print about 40 to 300 characters per second. Okay, Mujuruzi, I will ask you to unmute, and then you ask your question. Mujuruzi, please unmute.
Yes. My question was on the type. Sorry to take you back, but my question was on the typewriter.
Okay, on the typewriter.
Yes. Now those stamps that they use, like to stamp, let me say, documents. Like, can you compare them to a typewriter? Because a typewriter, when you what I've seen, when you're typing the letters, it's the ink that like slams it on the paper.
Yes.
So I'm wondering that, can you compare it to those stamps? Because
yes,
you basically put the letters that you want, and then the ink does the job.
Yes.
So can you compare them?
Yes, you can actually use that example to understand it better, understand it in a better way. But yes, you can compare it in that way. You can compare it, because when you look at the typewriter, the buttons you're actually pressing, they are connected to a certain hammer, which at the end of it has a shape or a character. So when you press the button, it hits the paper, and the paper leaves a character onto the paper, just like the way you're saying with the stamps. You hit the stamp on the paper, and it leaves whatever is on the stamp on the paper. Mujuruzi, that's a good way of understanding it. It means you have understood the mechanism, the impact, the impact printers use. Okay, so I'm going to lower your hand, and I hope I have answered you, Mujuruzi. I hope you're satisfied.
Thank you, sir.
Okay, all right.
Yes.
Okay, so let's continue with our lesson. All right, now we are still on the dot matrix. We are still on the dot matrix. I was telling you that the dot matrix can print about 40 to 300 characters per second, which is a very small speed compared to the printers we're using right now. Actually, when we come back to our non-impact printers, you'll notice that these impact printers are actually they are nothing compared to the printers we are using right now, because the printers we use right now print very fast. They print very fast. Now this one is only printing about 40 to 300 characters per second. Okay, so someone is asking, dot matrix printer is an impact printer that prints using a fixed number of pins or wires. Yes, Darren Subuga, thank you. You're just adding more to what I've already said. Okay, now The other examples are the daisy wheel printer, and the other examples are the daisy wheel printer. Okay, now the daisy wheel printer, like a typewriter, but with preformed letters at the ends of the spokes, form a wheel. Okay, now if we look at the next, image here, this is how the wheel in these printers look like. You'll see that at the end of those wheels we have the characters, the different characters, the letters, the numbers, 1, 2, 3, 4, they are all on the wheel. So all it needs is a magnetic ribbon, an ink ribbon, and the paper onto which these characters will be put on by striking method, by the striking mechanism. So the daisy wheel printer, instead of the characters being put at the ends of the hammer, they are put on the wheel. Okay, that's why we call it the daisy wheel printer. Now the difference between these two is that this one uses pins, a set of pins for drawing the characters. Meanwhile, these ones, they have the characters already put on the wheel. All it needs is to strike them onto the paper. Okay, all right. So what are the advantages and disadvantages of these impact printers? Now you'll notice that the impact printers are not very expensive because they were the very first ones. When we look at them right now, they are not expensive, but they can withstand dusty environment. Remember at the beginning of the printer section, we were saying that these printers can actually withstand very harsh, conducive environment. Okay, someone is asking, was a typewriter a computer or a printer? No, it was not a typewriter or a computer. Francis, it was actually a word. I don't know. Remember, I think you have all typed work in your computers using Word, the Word application. When you're using Word, the typewriter is a type of a word processor, but a manual one. Okay, the word processor we are using in our computers for writing our Word documents, is a word processor which is not mechanical, okay, or which is not manual. The typewriter was or is a manual word processing or a word processor, okay, for writing word documents. So it was not a computer. It was just a word processor, but a manual one. But actually, the way the Word, the Microsoft Office Word we are using right now came about was from the idea of the typewriters. That's why you'll see it has a keyboard, it has something to print out, it has a paper onto which it is striking direct or typing the words direct. So it is just a word processor. Okay, I hope I've answered you. Okay, Roman, we shall come to that. Everything about printers you will know. Then we say they can print through multi-part forms, creating several copies of a page at the same time. So here you can actually type, you can print copies using the impact printers. You can print at the same time. You can print a duplicate or a triplicate even at the same time. It's an advantage. So the disadvantages are that they are slow when printing. When we compare them to the printers we use nowadays, these ones are slow. They cannot even print graphics. What do we mean by graphics? I already told you what graphics is, either image or video. So these ones can't print graphics. Here now we talk about the images because you can't print a video, okay? When you print a video successfully, you will let me know, and I don't know what I will do for you. But you can't print a video, but you print images, okay? Thank you. Now, the print quality is low. Imagine. Now, what is a triplicate? Okay, entirely triplicate, like duplicate. When we talk about duplicate, we have 2 copies. A triplicate, 3 copies. A quadruplicate, 4 copies. Those are just words to mean how many copies we have. A triplicate is standing for 3 copies. So the other disadvantage is that they are very noisy because of the striking mechanism. Because each time the hammer is doing its job, making a lot of noise, you find things become noisy. Okay, so those are the impact printers. Okay, now let's look at the non-impact printers. Now the non-impact printers, the word non-impact is the opposite of impact. Here now we don't have any striking mechanism. Here, instead of hitting of the mechanism for hitting and striking, we just make use of, we use certain technologies like the laser lights. Okay, we make use of technologies like laser light. We make use of technologies like inkjets. Now, the non-impact printers form characters and images without direct physical contact between the printing mechanism and the paper, just like we saw in the impact printers. So the examples here can include the inkjet printers, the thermal printers, the laserjet printers. So we're also going to go through these one by one. This will be where we shall end our lesson for today after I'm done explaining the laserjet printers. So now, the non-impact printers. So the laserjet printers make use of the laser light technology. They make use of the laser light technology. Here, the images or the words or the characters, they are created with dots. But as in a photocopying machine, these images are created on a drum, treated with a magnetically charged ink like toner. Okay. Now, the toner is going to produce dots, which are going to be put onto this paper. Okay. Then they'll be transferred from the drum to the paper. So when we put papers in these printers, the papers actually move through the printer. They move through what we call the drum. They move through what we call the drum or the toner. The toner does the job of making sure that the characters and the images are going to be created using the dots. Okay. So after that, the paper is then transferred. The ink is then transferred from the drum to the paper. Okay, the laserjet printers. So just because our time is running out, we are left with about 2 minutes. In those 2 minutes, I would like to just explain the inkjet printer, and then we stop here for today's lesson, and then we shall continue from here next week. So the inkjet printer also forms images with little dots, except that the ink is going to be produced, the ink for printing these images and the characters will be produced from a nozzle. Okay, we have what we call nozzles in these printers, which have small holes through which the ink can be sprayed onto the papers. So in these printers, this ink is actually always electrically charged. Okay, it's always electrically charged. So the inkjet printers can print in color. Okay, so the color printers are the examples of the inkjet printers, and they are quieter and much less expensive than a color laser printer. So, however, they are slower and print in a somewhat lower resolution. So the resolution they use is slower. Okay. So for today's lesson, we are going to stop here. I'm hoping that there are no questions. I appreciate all of you for attending. I'm going to share some links for the videos to help those who didn't attend the lesson. The videos are going to be in terms of links so that you can download them. Okay, they are going to be the videos for this same lesson we have just had.
Okay, thank you, sir.
All right. So I hope there are no more questions. I thank all of you for attending. I thank Mr. Mutambi. I thank Mr. Mukulu for being part of our lesson.
Thank you.
So thank you for the lesson.
Thank you, sir.
Right. Okay, you are all welcome. So
Thank you, sir.
Have a good day, and thank you all.
So I'm taking computer.
Thank you, sir.
God bless you, sir.
Thank you.
Thank you for the lesson.
Sir, thank you for the lesson.
Thank you for the lesson, sir.
Thank you, sir.
Boom.
Teacher, thank you for the lesson.
Okay, you are all welcome. Have a great day and bye.